Okay, so here you see the circuit I had to build for creative electronics. This circuit collects a charge when the button is pressed. This charge is collected within the capacitor. So when the button is released, the lights in the circuit will burn for the time the discharge of the capacitor generates enough voltage to keep the op-amp in a high state. So for the first question, what is the effect of the switch at the minus input of the op-amp when pressed and when released after being pressed? When you press the button, the tactile switch connects the minus input of the op-amp to the ground, creating zero voltage at this point. Resistors are dividing the voltage throughout the circuit. Due to the voltage at the plus input being bigger than the zero voltage at the minus input, the op-amp goes into a high state. Once you release the switch, the connection is broken again, so the minus input has no connection to the ground anymore. Due to this, the charged capacitor will start discharging through resistor 1, creating a slowly rising voltage at the minus input. For the time the minus input stays at a lower voltage level than the plus input, the output remains in a high state, keeping the LED and the lamp on. Once the minus input voltage surpasses the plus input voltage, the op-amp will switch to a low state, causing both lights to turn off due to not enough voltage releasing from the op-amp. So now we're going to talk about the time-dependent behavior of the plus input, minus input, and output voltages of the op-amp. So in the circuit, the resistors work as voltage dividers due to voltage taking the path of least resistance. So there can actually be differences throughout the circuit. So first talking about the plus input. The plus input does not change because there's only a resistor from V supply to the plus input. Of course, if you neglect a small change in heat within resistor within the circuit, not a lot will change. So then talk about the minus input. When you press the switch, the circuit closes. Zero voltage will be at the minus input due to the voltage going to the ground and thus the light. Once the switch is released, the voltage will slowly rise with the capacitor discharging till it surpasses the plus input again and the lights turn off again. And then of course the output. This has a low output voltage when the minus input surpasses the plus input and a high output voltage when the minus input is lower than the plus input. So now in the next question, what's the role of the capacitor? Sorry. So the capacitor has the ability to store voltage. When you click the button, it will start charging, and when you release the button, it will slowly discharge because there's no voltage going to the capacitor anymore. This discharging is why the light keeps burning till the minus input at the op-amp surpasses the plus input again. So now let's continue to the delay period. Which components determine the delay period and why? The capacitor and resistor 1 determine the delay. The duration of the delay is decided by the capacitance of the capacitor times the resistance of the resistor. So if the resistance, capacitance, or both increase, the duration of discharge will also increase. So if one component or both decreases, then the duration of the electrical discharge will decrease. Here we're talking about resistor 1. Now let's go on to the next component, being the MOSFET. What are the relevant properties you consider when choosing a MOSFET in a circuit like this one? The MOSFET can be seen as some kind of switch, but it works by itself. It closes when the supply voltage from the op-amp is high enough. So this is when it's in a high state, making the voltage reach the lamp. When it's in a high state, there's enough supply voltage coming in into the MOSFET, and it will close, so the current can actually go through the lamp. Yeah. So it also functions as some kind of resistor. It takes care of not too much current flowing through to the light. Of course, the MOSFET will due to this heat up. Yeah, it's kind of how a resistor works. That's logical. To kind of fix this, for your MOSFET not becoming too hot, it will be ideal to place a resistor before your MOSFET. So the biggest part of current is already held back. You have to be sure this is still above the output current of the MOSFET, because if it isn't, then it could be too low because it cannot really increase the current. If you do this, you can also try to prevent overheating of the MOSFET because too much current is going through, or not really going through, but resisted. And now we're already going to the last part, which is about the resistor and switch. What is the role of the 1K resistor in series with the switch? So when too much current goes through a switch, it is possible the electrical sparks kind of like, how to say it, overrule the actual switch. So there could come electrical sparks between the legs of the button, as I call them right now. The iron thing is the button. If this happens, of course, the switch is neglected and not really used anymore. So when the current is decreased, this cannot happen within the switch. And also, as we talked earlier, it's also so the capacitor discharge time is also set in a current way because of this resistor. And this is the end. So thank you for listening.